Thank you for that introduction, and thank you for having me here at NAVAS. As told, I am doing a part-time PhD project together with Jan, and he asked me to talk today about TIVA versus inhaled agents, time to regain our balance. And this wasn't really an easy task for me, because when I had to do my literature research, of course, because this is completely out of my comfort zone, it's nothing what my PhD is about, really. And indeed, as Slinger also writes, when writing or speaking about the topic outside one's own area of expertise, by example, climate science in medical literature, care is required to avoid inadvertent distortion of information and citations. Anyhow, I will tell you something about what I learned through this literature research about TIVA versus inhaled anesthetics. And often it's mentioned as well, do we as healthcare have a special treatment because we treat patients? Do we get a special treatment? Is there a form of healthcare exceptionalism in this department? Are we ignoring environmental harm caused by inhalation anesthetics agents or healthcare in general because they are considered indispensable? Well, let's look at the balance, and of course there are these questions: do we need to ban volatile anesthetics, or do we need to ban all volatile anesthetics? And are we going from a volatile anesthetic era to a total intravenous era? Let's look at the balance and look at both sides of the story. And if you look at environmental impact, you have the carbon footprint causing global warming, as you all know, and the ecotoxicity of a substance. And if we start with our volatile anesthetics and the carbon footprint of volatile anesthetics, we all know that our volatile anesthetics are greenhouse gases. They contribute to global warming, and you can find several numbers in literature, by example, that globally healthcare sector is responsible for 4 to 6% of the greenhouse gas emissions. Volatile anesthetics are responsible for about 3% of the healthcare-related carbon footprint and 0.02% of an anthropogenic climate impact. And they are greenhouse gases because they have a radiative efficiency, but they have a quite short-lived atmospheric lifetime, which makes it sometimes hard to compare them with other greenhouse gases because they are much longer, have a longer life in the atmosphere, the Joule cycle. A metric often used is a GWP. However, there are some questions if this is really an adequate metric. I'm not going to go into that. And some of our volatile anesthetics are also ozone depleters. And you probably all have seen such tables in which you can see that desifrane has the highest GWP effect, sevoflurane the lowest. Sevoflurane has the shortest atmospheric lifetime, and nitrous oxide the longest. And then this follows in a few recommendations that is often already employed in various hospitals. These are avoiding desifrane and nitrous oxide. Sorry, my mic is annoying me. And low flow anesthesia when volatile anesthetics are used. And decommissioning centralized nitrous oxide because there are a lot of leaks in the central pipes that cause a lot of waste. And you can see here in graphs results of this. Some hospitals where central supply system are cut off, you can see that the clinical use equals the system supply. And in hospitals like in Vancouver and Singapore hospitals where there is a decrease in desifrane charts. Of course, there is also this ecotoxic effect of volatile anesthetics. Help me. And this has come recently into our attention, that volatile anesthetics belong to PFAS. You can find the worries about PFAS everywhere in the news. Example, we cannot eat our eggs from our own chicken because there is too high or possibly too high PFAS concentrations. And recently there is this article talking about volatile anesthetics and PFAS as forever chemicals because they are non-degradable in nature. And our volatile anesthetics are PFAS because of their chemical structure, of course. We have the CF bonds in volatile anesthetics that are extremely very strong and are very resistant to degradation in nature. But there is also this reason that they have this structure because halogenation, so the replacement of one or more hydrogen atoms in this organic compound by a halogen, in this case fluorine, increases anesthetic potency. There are numerous of definitions of PFAS. Some say it should be a fully fluorinated carbon atom, some say at least one fluorine atom. But because of this several definitions, it makes it sometimes even more complicated. You can find PFAS everywhere. You can find it in stain-resistant furniture, fast food packaging, cosmetics, but also in pharmaceuticals. These are some pharmaceuticals that meet 9 different PFAS definitions. You can see fluoxetine and atorvastatin also belong to these. And here are others listed that also could belong to PFAS according to a definition. Also in medical devices, you can find it really everywhere. And it is the concern because of the bioaccumulation of PFAS. According to their length, how longer the length, the more tendency of accumulation, and because they are non-degradable, they tend to spread over long distances through air and water, so you can find PFAS products far from where they are really produced. When ending up in humans, it's learned that they are rather stored in liver and blood. They are suspected to be carcinogens and reproductive toxins, may have effects on liver, blood lipids, thyroid hormones, immune system, and reproductive system. However, we still have limited data what it really causes and what it really results in. So let's look at the other side and let's look at propofol in TIVA. You probably also know the carbon footprint of propofol is known to be very low because it's by definition not a greenhouse gas, so we look at the packaging and electricity used when propofol is administered, and this is a study from Jouwena where you can see several volatile anesthetics and several scenarios compared to propofol, where propofol is the lowest. And that's why it's often recommended that in mitigation strategies it's avoiding inhaled anesthetics and using intravenous and regional anesthetics when clinical applicable. But also propofol has an ecotoxic effect. Propofol gets wasted a lot, up to maybe even 45%. It ends up in the bin, and if it's properly degraded, it's usually by incineration, but it also ends up often in our water systems. And propofol, when it's administered in human beings, it's get metabolized by glucuronization, and 70% is readily eliminated, 1% of it even unchanged, and also ends up in the water systems. And propofol itself, if you look at an ecotoxic score, a PPT score for persistent bioaccumulation and toxicity is 6, which is not too high but also not too low, then it's often looked to the predicted non-effect concentration versus the predicted environmental concentration, which in this case is 0.4, which is lower than 1, and said that it has a low toxic effect. However, here again, there are inadequate qualitative data on ecotoxicity on aquatic ecosystems. And then we investigated the toxicity of propofol conjugates. Another side note that is also often mentioned is that the formulation of propofol consists 10% of soybean oil, which could be gotten from the Amazon and maybe intensify the deforestation of the Amazon. And then if we do go for a total intravenous era and switch, what happens if we use more and more propofol, or the demand of propofol increases? What happens then? So if you look at the balance, and in literature you can find a lot of opinions. Some say we should go and use TIVA as our first choice maintenance anesthetic strategy. Others still think that shifting to a total intravenous anesthesia is associated with environmental risks of its own, or making cases for death strain. And again, others are in the opinion that we need more data to make such a serious decision. Of course, the patient is still number one, and we have to look at the clinical benefits. However, none of them are really superior. Maybe propofol in the post-operative period because they cause less PONV and less post-operative delirium. And in literature, you can find a lot of approaches to sustainable anesthesia. There are some examples. For example, the Dutch approach, which is described in literature, and they apply TIVA when possible, inhalation anesthesia when necessary. And they write also about the worries about control over anesthetic depth, the loss of end-tidal concentration monitoring, longer time to awakening when too much propofol is administered, and loss of the comfort that comes with many years of experience with anesthetic gases was offset by the recognized gains of TIVA, which includes less nausea and agitation. And also here's an example of a university hospital in Zurich, where they implemented sustainable practices at their study center, which included discontinuing of nitrous oxide and desflurane, avoiding excessive fresh gas flow, intraoperative and oxygen levels, and limiting inhalation anesthesia to specific indications that are listed on the right side. So do we need to ban all volatile anesthetics, or do we need to ban volatile anesthetics from January 2026? In the European law, desflurane will be prohibited except when use is strictly required. But does that also need to be for all volatile anesthetics? Are we going from being from a volatile anesthetic era to a total intravenous era? Are we going from being gas for men and women to TIVA men and women? Still questions that are unanswered, and we have a lot of unanswered questions. I think a quantitative comparison of TIVA versus volatile anesthesia with all-inclusive life cycle analysis, including everything that comes with it, for example, the CO2 canisters in volatile anesthesia, with quantitative data is still missing. But then again, do we have time? Is global warming catching up on us? We don't know. Thanks for your attention.